Today we're going to talk about something called the reflex arc. So we've got a lot going on this week. So Tuesday, when you guys come in tomorrow, we're going to take a practical on the parts of the anatomy of a vertebrae or of a spinal cord. So you're going to have to know all the parts of the dorsal column, the gray matter versus the white matter, those sorts of things. But I'll go over it again with you here. And I think that's important. I think it's important that you understand anatomy in the context of it's something real, right? Not in the context of paper and pencil answering questions. So at any moment when you can do science, I think it's more important and more valuable to do that, right? Anatomy in real life doesn't happen on paper with pencils. You know what I mean? It happens with you cutting and examining. And so I think it's important that you get evaluated that way too. That's why I really like practicals. Okay, so let's go over some basic stuff first, and then I'm going to add something called the reflex arc. Oh, going back to our plan. So Tuesday you guys are going to be doing that, and then Friday when you guys come in, I'll see you for class period, and then I'll also see you for lab period. But I think what I'd like to do there is take both of those times that I have with you and do a lab activity. So there's a really cool lab on the reflex arc. So you guys will be doing reflex tests on each other, okay? And it's really cool. And you'll understand why your doctor does the things that he or she does when you get to do them yourself too, and the importance of them. All right, so this is our cross section of the spinal cord. We've got our dorsal horn or lateral horn or ventral horn, lateral horn, dorsal horn. Okay, central canal. So remember, our dorsal column would be up here, right? Up here we'd have gracilis, fasciculus gracilis, and fasciculus cuneatus dorsal column, right? It's sensory structure. All right, so let's talk about something called the reflex arc. So the reflex arc is very simply an arc, so going from a receptor to the spinal cord, to the central nervous system, and then back to the effector. Okay, so let's go over some components of that. I'm going to stick with the black marker for now because we're still drawing things in. So this is the dorsal side. So these would be the dorsal rootlets here, right? And remember, it's symmetrical, so both sides the stuff's going on. Dorsal rootlet, dorsal root ganglion, dorsal root, and then it's going to combine with the ventral root, okay? So we've got our ventral rootlets here, becoming the ventral root. And then the ventral root is going to combine with the dorsal root and become the spinal nerve as it exits through the intervertebral foramen. Okay? Let's go over some basics here. So this is the dorsal column, or this is the dorsal nerve, the dorsal root ganglion, dorsal rootlets. So this is sensory. Okay, this is sensory. This is dorsal. This is the dorsal side. So it's a dorsal root ganglion, dorsal root. This is dorsal root 2, and this is the ventral root. Okay, and this is motor. Okay, these are motor neurons, sensory neurons. Okay, so let's go back to some basics here real quick. So we've got our sensory structures here, we've got our motor structures here. If it's sensory, is it going towards or away from the central nervous system? Delaney, is it going towards or away from the central nervous system if it's sensory? Perfect, thank you. Yeah, so here's our sensory information. So this is sensory, this is motor, this is mixed. This is mixed fibers. So here's our sensory coming this way. Now, in the dorsal root ganglion, that's gray matter outside of the central nervous system. That's why it's called ganglion. And so this is where the cell body is going to be located. Now it's going to continue on through the dorsal rootlet. Now we're in the dorsal horn. once it's in the dorsal horn, it's going to do a couple things. It's going to have some collaterals, which we'll talk about later, right? That are going to go off to the side. One's going up to the brain to let it know what's going on. That's important. But over here, what it's going to do is it's going to synapse with an interneuron. Interneuron. Kylie, do you remember what an interneuron is? Kylie, do you know what an interneuron is? Alyssa, do you know what an interneuron is?
No.
Okay, so an interneuron is just a little jumper piece, right? So there's a cell body, right? It's gray matter. That's where our cell bodies and our unmyelinated axons are. So there's a cell body, and it's just a little jumper piece like that. That's an interneuron. Okay? Just a little jumper piece. So it goes from our sensory neuron to our interneuron. It's an interneuron right there. And it's going to synapse. You want to take a guess real quick as I draw it? What's it going to synapse with? So this is a somatic motor neuron. Somatic motor neuron. All right? Now, what is a somatic motor neuron? A somatic motor neuron is going to innervate what? Remember, we've got autonomic and somatic. What's a somatic motor neuron going to innervate? Anybody? So there's also autonomic ones in here, over here in the lateral horn. These are motor also. So if it's somatic, it's going to innervate a skeletal muscle. Right? It's going to innervate a skeletal muscle. Okay? So this is our basic reflex arc. I'm changing my little, I'm going to move this guy just a little bit. Okay. So this is our basic reflex arc. So we've got sensory information coming in. We've got sensory information coming in, and then we've got motor information coming out. Okay? Also collateral letting the brain know. Right? Basic sensory reflex arc. Right? Questions about that? Because we're going to take her a little step further. Okay. So your basic reflex arc works like this. So let's say, and you guys are going to be using these in class here. So this is a Taylor reflex hammer. That's what this is called. And we'll go over some specifics. We'll go over some muscle spindle reflexes and some Golgi tendon reflex. So, for example, when you're at the doctor's office and he hits you with one of these right below your kneecap, right? Boom, he hits you right below your kneecap. Okay, your leg goes like this, right? Your leg goes like this. The reason that happens is because that's a muscle spindle reflex. So we'll get to this in the specifics in a second. So the muscle spindle reflex fires. Right, so it's reached threshold, negative 55 millivolts, reaches threshold, depolarizes at the trigger zone, right? The axon hillock in the initial segment comes along here. So here's our action potential generated. Interneuron, motor neuron, alpha motor neuron, and then back to the muscle, and the muscle contracts. Okay, that's your simple reflex arc. Okay, so now let's talk about some specific kinds of reflexes. We'll get through two of them today. We're going to talk about one, the muscle spindle, and then two, we'll talk about the Golgi tendon reflex. All right, so these are two reflexes that we're going to talk about. And I'll give you a little bit of homework to practice this stuff. So let's take this, let's say this is your quadricep here, okay? Here's your quadricep. So this is the top of your thigh, your quadricep group up there. So we've got your quadricep. Your quadricep becomes the patellar tendon, surrounds the patella, right, your kneecap, and then goes down and inserts. Does anybody quickly remember where this muscle, where the quadriceps groups inserts? Oh, nobody, really. So it inserts on the tibial tuberosity. Okay, so it's your quadricep, there's your patellar tendon, there's your patella, there is your insertion on your tibial tuberosity. So this is a bone, right? And then you got your patella here, there's the tibial tuberosity there, there's a bone coming down like that, right? And on the back side of this, you recall, you've got gracilis. There's your calf muscle, soleus, right there. So this guy, there's a muscle there like this. That goes down to the calcaneal bone. Okay, so this is your quadricep. So this is how the patellar hammer, the patellar reflex works. Okay, this guy. So inside your quadricep, there is a receptor. Let me use blue. There's a receptor in there, and it's called a muscle spindle. Okay, so this is an actual receptor, and it's called a muscle spindle, and it is a stretch receptor. So once it's stretched, that'll cause it a mechanoreceptor. That causes it to depolarize and generate an action potential. Those action potentials that are generated, right? So here's our sensory neurons, right? They're going to all kind of come together right now because it's a convergent pathway, right? So they're going to come together, and then they're going to travel, and they're going to go in to the dorsal root. All right? We're going to go through the dorsal root. I'll just redraw this guy. I'll do it real quickly here. That guy. Okay, so it's going to come into the dorsal root. So this stretched, and we'll talk about why we have this reflex, okay, here in a second. So that's stretched, and now here it comes, and it's going to go dorsal root ganglion, dorsal horn, and then it's going to synapse with a motor neuron. Let's get this guy. So dorsal root, ganglion, here, and then we've got a dorsal. It's going to synapse with a motor neuron. Same color. Motor neuron, ventral horn, ventral root. Now watch this. It's going to come down here, and this is going to have neuromuscular junctions with the quadriceps groups. Okay? So once this fires, there's also collaterals here too. This is going to go up to the brain. I'll let you know you got hit with a hammer. Right? To your brain. So when this guy fires, this gets stretched, action potential is generated, alpha motor neuron, muscle contracts. So the muscle that is stimulated, the muscle that is stretched, is the muscle that contracts. So why would you want this to happen? Well, let me kind of explain it to you how I see it in my mind's eye. So imagine us evolving this. Let's say you're in a cave, you're a caveman, right? You're out doing caveman things, living in caves and being a man. So, and you want some squirrel, like you're hungry, you know what I mean? So, and you look over, you're like, oh, there's a squirrel. I keep my squirrels over here under this rock. And you reach over there, and a coyote grabs your arm and pulls you like that, right? What do you want your response to be if something is yanking you suddenly one way? What do you want your response to be and why? Well, come on, this isn't hard. Who wants it? Lane, why?
Just pull back.
Just pull back. And why would you want to do that?
To try and get your arm out of its mouth.
Exactly. Or to keep your shoulder from becoming dislocated, right? In order to keep the humerus from coming out of the glenoid cavity, right? So, yeah, exactly. So that's what this does. And this is how it works. So you guys are going to be using this Taylor reflex hammer. So there's the patella there. Just below the patella, you're going to strike the patellar tendon. What that's going to do is that's going to pull. That's going to pull this, and that's going to stretch the muscle really rapidly. That rapid stretch causes this stretch receptor to depolarize. Action potential is generated, right? Synapse. Alpha motor neuron. Muscle contracts. Leg kicks forward. Okay? Everybody go to that one. Now, let's talk about a different one. So that's called the muscle spindle reflex, and we do that with the Taylor reflex hammer, okay? Now let's talk about another one. This one's going to be located inside of the tendon itself, all right? So this one's going to be located, I'm going to do this, right? So I'm going to I'm going to do an exploded view of that guy. And I'm going to take it right over here. Okay. So let's say inside of that tendon. Okay, so we've got our tendon here. So there's our muscle. Right? And then we've got our tendon going down like that. And then we've got our patella. Right? Like that. Okay. So there's our patella inside here. All right, located inside of tendons, there are other stretch receptors, and these ones are called Golgi tendon receptors, and they're also a stretch receptor. Okay, they're also a stretch receptor. And how they work is this. They send a signal also. Let me redo this guy. So they also send a signal, but rather than sending an excitatory signal, they send an inhibitory signal. If they're sending an inhibitory signal, then what is that going to do to the muscle? Is it going to cause it to contract, or is it going to cause it to relax if it's inhibitory? Danielle. If it's inhibitory, is it going to cause the muscle to relax or contract? You can't not answer. Oh, there you go. Contract. Yeah. No. Inhibitory. So this is excitatory. It excites it, right? Wham, contracts. This one's inhibitory. It's going to cause it to relax. Watch this. So here comes our signal. Now the tendon. This is the muscle. Muscle gets stretched. Muscle contracts. Makes sense. This is the tendon now. Tendon stretches. It sends an inhibitory signal. Right? Dorsal root. Dorsal horn. Now this one is going to have an interneuron. This one's going to have an interneuron. And then the interneuron is going to synapse. Interneuron. With a motor neuron that's inhibitory. Okay, so this one's going to come down. It's going to synapse, but it's inhibitory. Okay, so that's going to cause the quadriceps to relax. Okay, and the same thing here. This one's also going up to the brain. Right, let you know that something's going on. So this happens, for example. Hey guys, what's up? Oh, let's get some laptops. So this happens, for example, if you're picking up something really heavy, right? If you've ever seen someone on like a bench press, right? And they're going, oh my God, it's so heavy, and they just can't, it drops, right? Or a squat rack, right? They get up and they start going and just boom, they collapse, right? They get squashed underneath it. Why would you want this receptor, this stretch receptor in the tendon to cause the muscle that's pulling on it to stop? Why would you want that? Ben.
I'm not sure.
All right, so watch this, Ben. All right, watch this. So this stretch receptor, right? This stretch receptor, it's like I'm pulling on the muscle. The muscle's pulling. Oh, pull it back. I don't want to get injured. Okay? Excitatory signal. This one's not in the muscle. It's in the tendon. Okay? So the muscle is doing whatever. Don't worry about the muscle. If the tendon starts to stretch, why would it want the muscle that's stretching the tendon to stop? Ben, back to you again.
Because
So I'm pulling this.
I don't know.
This is stretching, the tendon stretching. It's telling muscle, stop it. Why would it do that?
So it stops contracting.
Yep, and why? What's it trying to prevent? This guy's screaming. He's being stretched hard. The tendon. He's telling the muscle, cut it out, man, or else what's going to happen?
It's gonna rip or something.
Exactly, exactly. So that is trying to prevent tendon damage, which is horrible. Imagine, right, a time before hospitals even, and you tear a tendon, right? Now your quadriceps, for example, is no longer connected to your tibial tuberosity. What can't you do? You can't walk, right? So this is really important. So these two together prevent injuries, right? But wait, there's more. We also have the power, and I'm going to go over this again in a second. I'll put it all together. We also have the power from brain to generate IPSPs and EPSPs to either stop a reflex from happening, slow it down, or excite it. This is why your doctor, when he's coming around and he's hitting you with a hammer and stuff, he doesn't really care about what book you just read. I mean, there are other reasons he's talking to you, but he doesn't really care about the book. He's trying to take your mind off of what he's doing so that you don't generate EPSPs or IPSPs, and he can get an accurate measure of symmetrical responses. Okay? Hope that makes sense. So just to review here, here's what we've got. Our basic reflex arc, which I erased, would be from the receptor to the central nervous system, perhaps an interneuron, motor neuron, effector. Okay? Some specific examples. Stretch receptor. The receptor itself is called a muscle spindle. The muscle spindle is a mechanoreceptor. It fires with rapid stretching, generates an action potential, dorsal root, dorsal horn, synapses in the ventral horn with the motor neuron, alpha motor neuron, causes the muscle to contract. So muscle spindles cause the muscle that they're in to contract. Okay, Golgi tendon reflex. This is in the tendon, not the muscle. When this stretches, this causes an action potential to be generated, which goes into the dorsal root, dorsal horn, interneuron, and then synapses with an alpha motor neuron in the ventral horn. And this sends an inhibitory signal to the muscle, telling the muscle to relax. So Golgi tendon causes the muscle that's connected to it to relax. Muscle spindle causes the muscle that's connected to it to contract. Okay? Questions about that? Okay. I'm going to give you guys some homeworks, and I'll post it up on the classroom there. So we're going to do, if you want to write it down now, but I'll put it up there. We're going to do questions 4 through 11. Okay, 4 through 11 in chapter 12. All right, I'll put it in the Google Classroom. Okay. Any questions? We've got 6 minutes here. Does anybody have any questions you want me to address? Okay, so anatomy practical on the spinal cord today, cross section, tomorrow on the cross section, and your meninges. Don't forget your meninges and your spaces. Okay? Okay. All right then, I'll see you guys tomorrow in person. Have a great day.